Good afternoon, wonderful earth science kids. We're going to be talking about sedimentary rocks today. These are rocks that form from sediments. So the earth makes a lot of sediments, or a few different kinds of sediments, but most of the sediments just fall into three different categories. If you were to take a scoop of a stream that's flooding, for example, and it's got muddy water in it, and you scoop it up into a beaker and you let it settle, you're going to find that it settles out in nice little layers. And if you look at the stuff that's in it, you're going to find it's tiny chunks of other rock, mostly. There's also going to be a few living creatures in there, probably, but mostly chunks of other rock. So that would be the first kind of sediment, fragments of other rock. They might be something called chemical precipitates. Now, in the stream, in order to find the chemical precipitates, you're going to have to do what I did in this beaker, which is evaporate it all. And if you look close at it, all these different lines, that's what you get when you've evaporated all this stuff. Some of this stuff isn't chunks of things. Some of it's like salt. When you evaporate it, it leaves the salt behind, and it would leave that. So that would be a chemical precipitate. If you have an inland sea evaporating, you're going to get that. The other one would be organic remains. There's two main sources of organic remains that get preserved in the rock. One is like this, and if you look close on the surface of this, you can see a bunch of seashells, right? A bunch of seashells impressions. So this is limestone made of those seashells, just lots and lots of them. Sometimes those seashells, under such pressure deep in the ocean, they just turn into what they would call a calcareous ooze. And when they harden, when you have miles of that calcareous ooze and it presses itself, it would just turn into bulk limestone like this. No fossils in it, but it was made of shells. The other place we get organic remains is on the land when you have a swamp. Now, an odd thing about a swamp, when things die in a swamp and fall down in the water, you'd think the water is just filled with like bacteria and stuff that would eat it up. But it turns out that swamp water is pretty sterile. It's so acidic, bacteria don't live in it. So when a tree falls down in that swamp, it sits there. And over ages and ages of time, it slowly turns into this. This is coal. So that would be the major type of organic remains. And that's it on sedimentary rocks. They can be chunks of other rocks, chemical precipitates, or organic remains. So the two major types of sedimentary rock, well, if you look on your reference tables, it just turns them into clastic, which means chunks of other rocks, or non-clastic. And non-clastic is the chemical and organic stuff. Fair enough. So you can see here how it's basically done up. It gives you some just nice examples. If you have, for example, mud, some pressure turns it basically to shale. And it gives you some of the other things that muddish stuff might turn into. But for the most part, it's shale. Sand turns to sandstone. Gravel turns generally to conglomerate. If it's angular, sharp gravel that hasn't been tumbled far, it might be a breccia, but typically they're making conglomerates. The organic matter, well, we're making coal. Some of the organic matter turns to oil and gas, which is also something you find in sedimentary rock. But then these seashells really turn to limestone. We'll get into that. So sedimentary rocks are produced through a process called lithification. Lithification literally means to be turned to stone. So loose sediments are transformed to solid rock this way. The lithification process, number one, compaction, and then cementation. And the things that you can use to cement, calcite, silica, or iron oxide, would be typical cements. But in order to have lithification occur, you better do the compaction and cementation. That's important. So let's just take a look. The lithification, transforming sediment into sedimentary rock. Gravel, you compact it down, and if it's rounded clasts, there you go. You have conglomerate. If it's angular clasts, you have breccia. Breccia. All right, sand, You compact it, cement it, you have sandstone, silt, you get to siltstone, clay. No, it's not claystone, it's shale. Okay, and again, the common cementing agents are calcite, silica, or iron oxide. Why? Well, there's a lot of that around. Water passing through rock can dissolve some of that, and then when it precipitates it, then you have cemented that sediment together. So, typical sedimentary rocks, if it's clastic, right, that means chunk of other rocks, it's classified by size and shape. So, like conglomerate, breccia, sandstone, siltstone, shale, these are common. Take a look at this one. I see big chunks in that. What would that be? Well, the question would be, are they rounded or are they smooth? If you see big chunks like that, it's going to be conglomerate or breccia. Conglomerate if it's rounded, breccia if it's angle. So what's that? You're right. That is breccia. Well, what's that then? All right. Now, notice the hat for scale. That means these are really big, head-sized chunks. Question is, though, are they sharp and angular or are they rounded? And you can tell these are sharp. Whatever happened, these guys did not get smoothed off. So this also would be breccia. You can tell breccia is kind of unusual. Usually the pebbles and rocks that make this up have been rounded a little bit before they're deposited into rock. Typical piece of sandstone, if you look closely, you can see it looks like it's made of layers of sand. So if we take a photograph of a thin section of this, you could see these quartz sand grains here, and then you see the cement. Look at all that cement filling in all the pore space, or most of the pore spaces here, holding these rocks or these particles very, very tightly together. So that shale looks like that. You could break it with your hands. It comes in a variety of colors. Here's the typical red shale that you find around here. I whacked it with a hammer. I'd get chunks of this coming right off. A lot of times you pick it up and it falls apart in your hands. You can impress people by crushing rock in your hands. Don't try that with all the rocks, but works well with shale. Conglomerate, nice rounded stones, right? Look at those rounded stones. Where do they look like they've been? Sure, they look like they've been in a stream, and they probably have been. They've been rounded like that. That would be conglomerate. These round clastic fragments are cemented or somehow consolidated. They're conglomerates. And when the angular clasts are consolidated into something, they're called breccias. So notice right away, it gives you some history of the particles that are making the stuff up. If they're rounded, they've been water rounded in a pebble, rounded like rolling pebbles in a stream. If they're breccias, how would you ever get breccias? Well, how about a landslide where all the stuff falls down and then that stuff is buried and turned to rock right away without ever rolling or going away from where it was? That would be something that might turn rock into breccias. And these are standard limestones. These would be the chemical, or rather the biochemical rocks. So these are both limestones. One is a shell limestone. If you look closely here, you could see a bunch of little particles here, little shells. If you look really close, there's little shells making that up. This is formed from that calcareous ooze of limestone. So some features in sedimentary rock. Well, first of all, fossils. Fossils are going to occur in sedimentary rock. Don't have to worry about them in any other kind of rock. If I fall into magma, not a lot of me left to fossilize. And metamorphic rock, you'll see it gets so warped and distorted that if there were fossils, they're probably gone now. So some sedimentary rocks, like conglomerates and breccias and sandstones and shales, they have fragments of other rocks, sediments within them. Look at that. A lot of interesting fossil stuff there. Those are, I think, mostly worm burrows. Look at that. What a fun job to go dig out dinosaurs. Actually, probably a very painstaking, challenging job. But the fossils give us a beautiful window onto ancient life. We know a lot about what the Earth was like in the past because of the fossil record. So sedimentary rocks form in flat horizontal layers called strata. When I poured sediments in here, if you look at that, they formed nice flat layers, right? Just one sedimentary layer after another. So flat layers are known as strata. If I had filled this with just salt water a year ago and had left it on the counter in the sunlight, all the water would evaporate. But would the salt evaporate? No, salt doesn't evaporate. So salt would be left in the bottom of that. And that would be a type of mineral deposit known as an evaporite, which is what you get when all the water evaporates. The evaporite is left over. The typical ones would be rock salt, halite, rock gypsum, which we use for drywall in your house, and then dolomite is sometimes found also as an evaporite. Take a look at that. There's some sedimentary rocks for you. When you're out driving, you see sedimentary rock all over the place. Nice flat layers. The white lines going through them are the blasting holes that were used to actually blast that out for a road cut. That is definitely sedimentary rock. And where did that rock salt come from? Give you a hint. It's an evaporite. So what happened? An ancient ocean caught inside a continent where streams and rivers are coming in so hot, no rivers come out, it just all evaporates. You'd have salt left over and big, big areas that are left in salt, and that would be rock salt. So anything that's happened to an area that is recorded in the rocks can be kind of fossilized, and you can find it recorded in rocks hundreds of millions of years later. And there's a variety of neat sedimentary structures. Let's get into them. You could have cross-bedding. Cross-bedding is what happens in a sand dune. When it fills up with sand here, so it has to start piling on this side. Then it fills up here, it has to pile on this side. So it goes back and forth, cross-bedding. Not only do you find it on a sand dune, you find it on a fossilized sand dune. Ripple marks. Well, the ripples you see on an ocean floor or a gentle part of a river where it's a sandy floor and you get gentle ripples that leave ripples, clear ripples in sand. Mud cracks, mud dries out, you leave all the cracks. Well, that could get fossilized. You could find it in the rock. Graded bedding is when you have a flood, the largest particles go down to the bottom and then it gets finer, waiting for the next flood. Another flood, largest particles on the bottom going finer. So you can have episodes of graded bedding. So cross bedding in sand. Let's take a look at what this would look like. There you go. These back and forth directions in the sand. And you can tell it's actually sand, but once this is buried and turns to stone, you'll still have those marks. What else can you find in sand? Look at that. Ripple marks right there in the sand. You can have two kinds of ripple marks, one that shows waves, one that shows current. So geologists can figure out whether it was a running river or a shoreline just by looking at these ripple marks. All right, you can see the two different kind of ripple marks there. Then we have some example of ripple marks there. And look at that. There is a discovered surface. This used to be on the surface of the earth. This was exposed to days on the surface with water rippling up against it. And then it was buried, and it's been fossilized for hundreds of millions of years. But that represents a day in the earth a long, long time ago. Similarly, mud cracks in clay. You could get mud cracks preserved in the rock. So there's two general groups of sedimentary rocks. There is the clastic rock based on chunks of other rock. The material is solid particles. We classify it by particle size from biggest conglomerates, then to sandstone, siltstone, and then finally down to shale, which would be the tiniest particles. All right, and here's the abundant ones. Why would we point these out? Shale, sandstone, conglomerate. Next time you're outside walking around, look at rocks. If you're in the Catskills, the only rocks you're going to meet almost certainly are shales, sandstones, or conglomerates. Walk around the school grounds, that's what you're going to find. Everywhere you go around here, those are the rocks, the three rocks you will find. So the other group would be the chemical rocks, and it's either through life processes or precipitated as a result of evaporating oceans. Now, here is the stuff you need. Classification of sedimentary rocks in your reference table. Take a look at it. Clastic. This whole section here is then for clastic. And anything with large chunks, if it's round, it's conglomerate. If it's sharp, it's breccia. Easy as that. And then if it's a certain size particle, sandstone. Smaller, siltstone, even smaller, shale. Pretty simple. Crystalline, well, those are evaporites. Those are evaporated oceans. So the three kinds you have, halite, gypsum, and dolomite. Then the bioclastic stuff, you're going to have limestone or coal. So those are your choices. That's how we divide up sedimentary rocks. That's really all there is to it. It's made of sediments. Whatever can possibly be a sediment on Earth's surface, we got it there. Beautiful shale with plant fossils. I like that one. Sandstone. That's sandstone. What else can you say? It looks like sand. And conglomerate, right? Very easily to identify, nice pebbles embedded in it. Beautiful stuff. So evaporitic rocks. Evaporitic rocks form within a depositional basin from chemical substances dissolved in the seawater or lake water. The streams bring it in. Streams have a tiny bit of salt in them, tiny bit, and some other stuff dissolved in the water. You would never taste it because it's such tiny amounts. But if that empties into a lake and the lake evaporates, well, the only thing that evaporates is fresh water. All the other stuff stays behind. So over time, the lake gets more and more salty or filled with gypsum or whatever. The lake would concentrate it. Certainly, this is what's going on in oceans. But you need an inland sea to evaporate the whole thing. Regular oceans don't evaporate. But an inland sea certainly can. And if you look at the Great Salt Lake in Utah, it's an inland sea that is evaporating. And what do you suppose it's filled with? Salt. Yeah, like that. Sometimes you'll find a fossil bed in sedimentary rock that just makes you weep. It's so beautiful. Look at the fossils in this. You could study this for a while. Beautiful fossils. Not a lot of fossils right local to our area, but the Catskills does have some good fossiliferous beds. But what are the economic importance of sedimentary rocks? Well, there's some really serious economic importance. For our energy sector, coal, it's a sedimentary rock. Petroleum and natural gas, this is stuff that is laid down in sedimentary rock. You have to be a sedimentary geologist to understand where to find them. You also have sources of iron and aluminum, pretty important. So you can imagine, if you look here, where you have the coal, or rather, I'm sorry, where you have the oil here, the oil is not anywhere. The oil is in very specific spots. How would you make sure to put your very expensive drilling rig in the right spot? Well, for that, you need a geologist. Because if you put your drilling rig and drill right down in any one of these spots for all your work, you get nothing. A geologist, a good geologist, can tell you where to put your rig. And that's going to save you enormous amounts of money. And as a matter of fact, that's going to make you enormous amounts of money. So some of the big geology jobs are finding oil supplies for the world. Anyway, that's it on Sedimentary Rocks. Hope you learned some stuff. See ya on Metamorphic Rocks. Thanks for watching.